Welcome to today's session on solving quadratic inequalities with two variables. So when we're looking at inequalities with two variables, we're normally talking about x and y, our two unknowns, which are our variables, and we are going to be solving this when there's a quadratic involved. So here I've got y is less than or equal to x squared minus 2x minus 3. Now this is quadratic because the largest pair that we've got for one of our unknowns is the power of 2. So this part just here is a quadratic. We're going to make y equals 0 because we're going to solve this in much the same way as what we would do if we were solving a quadratic equation. Anytime that we're solving a quadratic equation, we need the quadratic equation part to be all on the one side equal to 0 on the other. So I'm going to solve this by factorising. I've taken a look at this and I've gone and seen that I need an x to multiply together inside my brackets to give me my x squared. Then I've looked at my negative 3. What two numbers can I get to multiply together to give me negative 3? But also those two numbers, which can I add together to give me negative 2? And my solution to that is positive 1, negative 3. Now, my solutions for this is x to equal negative 1 and x to equal 3. So to represent this on the number line, I'm going to use full circles because I'm dealing with my inclusive inequalities. So they could be equal to negative 1 when x is negative 1. They could also be equal to when x equals 3. But the next part is exactly where does the solution lie. So I've just copied this across, and now we are going to test some values either side of our inequalities, either side of our values that we've been given for x. See if we pick a value from there, from this side, and from this side to test it out. So I'm going to use negative 2. If I substitute negative 2 in for my x, I've got negative 2 plus 1, so that's negative 1. Negative 2, negative 2 minus 3, which is negative 5. Multiplying them together, that gives me positive 5. Positive 5 is greater or equal to 0. So I can draw a line going this way because all my values below or equal to negative 1, they will be part of my solution. Now I'm going to try 0 to see if any numbers within this region would also be part of my solution, would satisfy my inequality. So if I substitute in 0 for everywhere that I've got x, 0 plus 1 is 1, 0 minus 3 is minus 3, multiplying 1 by the minus 3, that is minus 3, and that is not greater or equal to 0. So my area here is not going to be part of my solution. Now I'm going to try 5 using my number 5 and putting this into my expanded brackets. 5 plus 1 is 6, 5 minus 3 is 2, multiplying them together is 12, and 12 is greater or equal to 0, which means I can draw an arrow going from my filled in circle going to the right hand side, in which case all values to the right are part of my solution. And I can rewrite this in bracket form, where all my values from negative 1 down to negative infinity, because of course from here the numbers go on and on and on and on, and they will be part of my solution. And all my values from 3 up to infinity, that will also be part of my solution. So that is just a bit of notation way of being able to write it. We can also show this using a graph. Just like when we're dealing with linear inequalities, we are going to use a broken up line to represent the strict inequalities, the greater than or less than, and everything along the line will not be part of the solution. And for the inclusive inequalities, we're going to use a solid line where all the values along this line will be part of the solution. So to give an example of showing this on a graph, I've got y being less than or equal to x to the power of 2 minus 2x minus 3. And that would look like this quadratic curve. Now I've used a solid line because I've got a inclusive inequality. And the area I'm going to shade in is actually outside of my quadratic curve. As another example, I've got a y being less than negative x squared plus 4, and that would look like this curve. And of course this curve would be flipped over from this curve because I've got a negative x squared. And for this one, all of my values inside of my quadratic curve, except for the line, are part of my solution. Now, if you're unsure about which region to use, which region shade in, always pick a coordinate inside or outside of your quadratic line and substitute it into your quadratic equation for x and in for y. In which case, let's say picking 1, 1, everywhere that you've got an x, you'll replace that with a 1, and you'll put a 1 for y, and that would, of course, tell you which region that you'd shade in if it satisfied that inequality. Just as a visual for those who work with visuals, visual learners, here's a little explanation of exactly which regions you can shade in for what type of problem that you are trying to solve and show graphically. If you want to take a look at this longer, please pause the video, or else thank you very much for watching.